Very good morning to all of you. Today I want to start experiment 8. Title of the experiment is Determination of Permanent Hardness by EDTA method for the given water sample or sewage samples. Okay. So today's course outcome is given for these titles and the subjects. Acquire capability to conduct experiments and estimate the concentration of different parameters. In second course outcome is compare the results with standards and discussed based on the purpose of analysis. Determine the type of treatment, degree of treatment for water and wastewaters. Next course outcome is identify the parameter to be analyzed for the student project in environmental study. So these are the course outcomes are decided. Title of the subject is Environmental Engineering Laboratory and the subject code is 18CVL67. This comes in 6th semester of Civil Engineering Department. Let us see, these are the apparatus are theirs. So these apparatus are continuous used in the environmental engineering laboratory experiments. So don't forget, so all these apparatus are used continuously. Okay. Now let us see concept of these experiments. Originally, water hardness was understood to be a measure of the capacity of water to precipitate soap. Originally, water hardness was understood to be a measure of the capacity of water to precipitate soap. Soap is precipitated cheaply by the calcium and magnesium ions present. Other polyvalent cations also may precipitate soap, but they often are in complex forms, frequently with organic constituents, and their role in water hardness may be minimal and difficult to define. In conformity with current practice, total hardness is defined as the sum of the calcium and magnesium concentrations, both expressed as calcium carbonate in milligrams per liters. What is the principle of these experiments? When indicator is added to hard water, the calcium and magnesium ions form a complex of wine red color with erythrome black tea indicators at pH of 10 plus or minus 1. EDTA has got a stronger affinity towards calcium and magnesium, and thereby by addition of EDTA, the former complex is broken down and a new more stable complex of blue color is formed. This is the principle of this experiment. Let us see which are the apparatus are used to conduct these experiments. Burettes, pipettes, conical flasks, volumetric flask, beaker, spoons, glass rods, weighing balance, dropper, etc. These apparatus are required to start these experiments. Okay. Let us see which are the reagents are used to conduct these experiments. So first reagent is EDTA of 0.1 molarity is required. So here to prepare this EDTA reagent, dilute 3.723 gram of EDTA salt and dilute to 1000 ml distilled waters, that is in double distilled water. Now it becomes 0.01 molarity of EDTA reagent. Next, buffer solution. Mix 6.75 gram of NH4Cl with 57 gram ml liquid ammonia and dilute to 100 ml with double distilled water. Now it's become buffer solution. Next reagent is erythrome black tea indicators. So use ready powder or prepared as follows. That is, mix 0.5 gram solochrome black dye with 100 gram sodium chloride to prepare dry powder. Now this becomes erythrome black tea indicators. As we are aware that the temporary hardness can be removed by boiling. As we are aware that the temporary hardness can be removed by boiling. The permanent hardness of water can be assessed by boiling the given sample, cooling it and collect in the filtrate and analyzing these sames. Okay. Now let us say procedures, how this experiment is conducted. Take 200 ml of well mixed sample, that is tap water, in a beaker and boil it for about 20 minutes so that permanent hardness remains. Next step, now take the boiler water, that is boiled water, and cool it and make it up to the original volume, that is 200 ml, by adding distilled waters. So now it's become 200 ml of waters. Next step, now take 50 ml sample. Now take 50 ml sample, that is from 200 ml sample, in a clean conical flask. Okay. The next step, now to the above solution add 1 to 2 ml of ammonium buffer solutions. The next step, add pinch of erythrome black tea indicators. Now the solution turns to urine red color to blue. Next, now titrate the sample with 0.01 normality EDTA solution taken in burette till the color changes from urine red to sky blue. Then note down the volume of EDTA consumed, let it be in mLs. Okay. Next, result we are getting, permanent hardness of the given sample is in milligram per liter. So see here observations and tabular columns. So in observation, in a burette 0.01 normality EDTA solution is there. In conical flask, 50 ml of sample plus 2 ml of ammonium buffer solution and a pinch of erythrome black tea indicator. So these are contained in clean conical flask. Indicator used, erythrome black tea indicator is used. End points, so here wine red to sky blue color is required. So this is the end points of this experiment. What is the tabular column? Say this format of tabular column. So here identification of samples, that we are writing tap water. Next, volume of sample taken in mLs. So we are taking 50 mLs. Means 2 trials. Next, burette reading. You enter IBR readings, FBR readings, and you calculate difference, that is FBR minus IBR. So that is EDTA consumed in ml. Next, hardness in milligram per liter as calcium carbonate we are getting. So then, like you enter the reading in this table. So we are taking 2 trials for tap water and 1 trials for distilled water. So then now we are calculating given that is obtained readings. Calculations. Now for water sample, permanent hardness in milligram per liter is given by the formula MBR into 1000 divided by ml of sample taken. So we are getting in milligram per liters. Now we know the relation total hardness equal to permanent hardness plus temporary hardness. So then temporary hardness equal to total hardness minus permanent hardness. So we are getting temporary hardness in milligram per liters. For distilled water, now you calculate permanent hardness in milligram per liter is given by the equation MBR divided by ml of sample taken into 1000. We are getting milligram per liters. Now same steps, total hardness equal to permanent hardness plus temporary hardness. So therefore temporary hardness equal to total hardness minus permanent hardness. Total hardness we have calculated in experiment 7. That value we are taking here. So we are getting temporary hardness for distilled water in milligram per liter. So now based on these results we want to write the conclusions. As per IS 10500 specifications, the permissible limit of the hardness in water is 600 milligram per liter, and they classify water into following groups: soft water 0 to 60 milligram per liter, hard water 120 to 180 milligram per liter, and very hard water greater than 180 milligram per liter. Then the hardness of tap water is found to be this much milligram per liter, hence the water is said to be soft water which can be used from domestic purpose. So this comment is based on the results. Okay, hardness of synthetic water means distilled water is found to be this much milligram per liter, that is n number milligram per liter, hence the water is said to be medium soft, and it also can be used for the domestic purpose. So based on the value, based on these range, you compare and write the conclusion. So this is the conclusions of these experiments. So these are the references are referred for these experiments to finish in details. Okay, thank you one and all. Next experiment I will be continue in next class.